Hello everyone, welcome to the class ECE341, the probability and random process course. Today is the Wednesday of the third week, and we will have the first homework due today. For the homework, I want to mention that each group you only need to submit one paper, but the other two have to put your name on the paper so we can know who worked together, and then I can give the grade to you guys, right? And another thing is even the other two do not need to submit the paper, but they still need to do the problem. All of you need to do the problem. This is kind of practice. That's very important. The thing is like you know how to do it. You also need to practice to make sure you really can do it. Now that's different. You know how to do it and you can do it. That's different. Similar thing like you ride a bike. When you look at someone else, they ride the bike. They just sit down and step on the pad and turn the direction, and they can go everywhere. But if you do not have enough practice, can you do it? I think you can't. You can know how to do it because you look at some other guys, they are ride a bike. You know how to do it, but you can't. You have to practice. After practice, you can do it. Similar thing. The homeworks, the not just our course, all the courses. Like the professor tell you how to do it, and the textbook also tell you how to do it, and some friends maybe you discuss with other guys, they also tell you, okay, this part you should do in certain way, how to do it. But if you do not have enough practice, you can't do it. So you have to do it. You have to do by yourself. If you can finish a problem, solve a problem without any help of others or any help of like internet, textbook, then you are done. You really can do it. If you solve the problem, but here or there you have to ask some other guys or search somewhere to find the information, then you are not done. You still need help of others. Only if you can do it without any help, then you are good. Alright? Okay, then let's go to the class today. Alright, today we will consider two theorems. The first one is, okay, let me write EC. This is ECE341. Today is the third week Wednesday class. Okay, and the topic today is two formulas or two theorems. So the first one is a law of total. Oh God, how to write? Total, T-O, right? Total probability. Yeah. Law of total probability. The thing like that. If B1 be some n is a event space. Remember what is event space? Oh, in the okay, this is the name in the older textbook. In the third edition textbook, it says it's a partition of the sample space. So event space is just the partition of a sample space. You separate the whole sample space into several pieces, right? There be 1 to be n. Then for any event, A, the probability of A equal to a summation. That is a probability A on the condition B I times probability of PBI, and do a summation. I run from 1 to n. 1 to n, yeah. So it is this one. It's a law of total probability. And the second one is Bayes formula. Bayes formula. The probability of some B over condition A under condition A equal to, this is a fraction. The numerator is PA on the B condition times PB and over PA. So this is a Bayes formula. So we have two formulas. Okay, now let's look inside what is the first one, right? We check the first one, try to understand it totally. We look at the statement here. We have an event space. We have a partition of the sample space for one, for the law of total probability. I use a graph to explain it. This is a sample space S, and separated into some B1, B2, B3, B4, and I have A. This is A. Then the probability of A. You see, here actually this A is separated as 1, 2, 3, 4, 4 pieces, right? In this graph, we have several small pieces. A is combined with small pieces, and each piece is A intersection B1, right? A intersection with B1, and A intersection with B2. We put union of all of these. A intersection with B, depending on the partition, B1 to Bn. So here's n, right? I can write A as a union of each small pieces, union of some small pieces. Each piece is the intersection of A with one of the event space, one of the BI. So we can write in this way. And then is equal to, okay, we use the formula, we use the axiom. Remember the axiom? You have several sets, you do a union and calculate the probability. There we have axiom, right? Of course, that axiom need a condition. Each piece, each part, they do not have intersection each other, right? And this is the case because we separated this sample space, so each BI, they are separated with the others, right? Intersection are 0, they are empty. So we satisfy this condition, then the probability of the whole union were equal to the summation of the probability of each small piece, right? We have this one. Okay, then we write this in terms of conditional probability. This is PA on the condition B1 times PB1. Am I good? You can check. P A over B1 times probability of B1. Right. The first term is this is 1, right? This one equal to the conditional probability is the probability of A intersection with B1 over PB1, right? And okay, you already know it, right? The second factor is this one, so they cancel. They are same, cancel. So this one times this one get PA intersection with B. So here's an intersection with B, right? A intersection with B1. The probability of this
equal to probability of A under condition B1 times probability of B1. You just copy this part to here. Alright, this is first term. And we also have, we have a lot of terms. So we do the same thing. For the second term can be written as PA under condition B2. Now it's B2, right? Just replace B1 by B2. This is probability under condition B2 and times probability of V2 until the last one. It is a probability of A under condition Bn times probability of Bn. Alright, we have it, right? This is just the law of the of total probability. Yeah, this one is a PA, right? It's a PA, and here we also have PA is this one. This one, right? Yeah, I can write it in one formula. This is a P, that is PA equal to summation of all of these. Each one is PA under condition B something, and times the probability of this B. And I will run from 0 to capital N. Right? Capital N here. So we have this one. Right? We have this one. And this graph also gives us the meaning. What is the total law of total probability? You want to have the probability of A. You can check what happened inside B. Right, B1 or B2 or B3 or B4. So here I use this one that is related with B1. Then if you have result here, then you say, okay, this factor happened. If you have result outside, then A didn't happen, right? So if B1 happened, then you can calculate the probability of A. Just use this part. And similar, if B2 happen, you can calculate the probability use the B2 part, and B3 and B4 and so on, right? You can always do the calculation like this. You separate in each pieces calculation, and then add them together, right? So here's a summation like this. Yeah. Alright. Okay, so this is a yeah, actually I prove it, right? I prove it. Yeah. This is the law of probability. And we can represent these in a graph way. A graph illustration. Something like that. This is we started the experiment, then you have the result, and the result might be located in the event B1. This is B2. This is Bn, right? You will have these. One of it will happen. And each one has a probability P B1, P B2 until P Bn. Right? You have this. And then you will check whether A happened. So you can see, you can just leave A here. I can put 2 like A happened, A didn't happen. A happened, A didn't happen, and so on. Here's A happened, A didn't happen. A didn't happen. Right? You can write it in this way. Then from B1 to A, that is under the condition of B1, the probability of A, right? So from B1 to A, under condition B1 happened, if A happened, then you can have the conditional probability. And here is similar. Conditional probability of A, now the condition is B2, and so on. And the last one will be probability of A on the condition Bn. A happen on the condition Bn. Alright. Then what is the total probability? All of these, put it together, we'll have probability of A. And what is the probability of A? Equal to this one times this one plus this one times this one. You will calculate along this. It's kind of a graph, kind of tree, right? Like a tree. The root is here. Root is here. Then go to the leaves. So here probability of B1 times this is one term. And then probability B2 times this, you get second term. And so on. Then you put all of these to a summation, you have this probability. So this is a summation of each P A on the condition Bi, these numbers, times probability of Bi, these numbers. And I run from 1 to capital N. Alright. So you can calculate the probability in this way. If you think it's hard to remember the formula, you can remember the graph. Right? The whole sample space separated as n pieces. All of them, you put them together, they will be the whole sample space. Right? Now you separate it as n different cases. On each case, if one of it happen, only one will happen, right? If one of it happen, like a B2 happen, then what is the probability from this case for A, and what is another probability? Actually, these two summations should be 1. All right. Yeah, you know one of it, the other will be 1 minus that. And then you just calculate along this way, along the tree, you have number to summation. Then you have the result. Alright. We can do an example. Like I have a box. I have some bars. I have 10 bars. 5 red, 5 blue, 5 red, 5 blue. I pick 2 times. I pick ball 2 times. And we want to know A is the event. The second ball is, for example, is red. Now what is the probability of A? Yeah, you take 2 bars, totally 10 bars. You take 2 out, but every time you only take 1. So you need to pick ball 2 times. The first time you will get some ball. It doesn't matter what it is. You will look at the second one, and we want to know the second one is red. The second ball is red. We want to know the probability of this. Now how to do it? Okay, this case you can separate the sample space into two pieces, right? So you can have a partition. Then you can use a law of the total probability. Like this. Okay. let's see, I separate in two cases. So the first bar, then we have second bar, right? First bar, second bar. We want to know this bar equal to red, or we want to know the probability, right? So first bar, we can have R here, blue here, and second bar, actually I have two possible, right? R here, blue here, and here's a R here, blue here, right? And I want A is second bar is red, so these two, this is A, this is A, okay. Our event A is here. And what is the probability? You need to check. First bar, because 5 red, 5 blue, so each is half probability, right? Half. The chance is half. And the second bar, that depending on the first bar. If the first bar is red, then you will have less chance to get red, right? After red, you have 9 bars left, and 4 of them are red. And of course, you can leave this blank. We don't need it. But here we can just do a study, right? You do some research to make sure everything. What is everything? Here B will be totally 9 bars, right? You pick 1 red, so you have 9 bars, 5 blue, 4 red. So here's 4 blue. So blue, there will be 5 blues, right? Like this. And okay, here, if first bar is blue, then you have 5 red left. So second bar is red, the chance is 5/9. And B is blue and blue. First time you get blue, so only 4 blues left, and blue again, so this is 4/9. So these are the probability of first bar, and we check the second bar, things like that. First bar is of course you need to separate it. Exactly speaking, here you need to say R happen or B happen, right? R or B, right? And you write this way, right? The value, I put it here. Then what is A? A is you do summation of these two terms, and each term is a multiplication of these two numbers. So it is 1/2 times 4/9 plus 1/2 times 5/9. And okay, what is the result? We can do a calculation. Half same, so I move 1/2 in the front, and inside is 4/9 plus 5/9. Oh, this is 9/9, right? Is 9/9. 9/9. This is 1. This is 1. So this is 1/2. Alright. So the second bar. The second bar is red. The chance of second bar is red is half. It's half. Right. And yeah. And we can do some. Let me see. We can have some similar examples. The thing like that. Another example. I have 10 bars. Still 10 bars. And now is 9 red, 1 blue. 1 blue. Then I have 10 people. 10 people. Now in a box. They are in a box. In a box. Right. Some bars in a box. You can look inside. You can see what's inside. Now 10 people. Each people pick 1. I use AI for the eyes people get that blue one. And we want to find PA1, PA2. I have 10 people, right? PA10. What are these probability? Are they same? I think we do these kind of things, right? You want it, for example, you have 3 people, or 10 maybe too much. I use 4. Can I? Yeah, I'm sorry. Yeah, excuse me. You make the calculation shorter. I just check 4 bars. Then the 4 and the 3 are red, and 1 is blue. Then each one pick 1 bar. So like we want to do kind of decision who will do something, right? Do some work or get some benefit or do some dangerous things, right? Things like that. Yeah, sometimes good, sometimes not good, but people can work like this. Who get that blue? Who will have that? Or that good or bad is something, right? Okay. Then we will. Because four people, right? 4 people. Who will pick the first do it? Who will be the first, right? People will think of like maybe the first will have more chance. Maybe the last one will have more chance. So here we want to calculate each one. Now it's just 4, right? Here's A1 to A4, PA2, 3, and PA4. I want to know this probability. If they are same, that will be very good. If some number is large, okay, you will remember. If last time you have chance to do these kind of things, you know which one will have the most highest probability. Now maybe you want to do that guy, do as that, right? Okay, let's do it. What it will be. Now we do the same thing. We start. Okay, then the first people maybe get red, maybe get blue, right? If the first one get blue, then okay, it's finished, right? No more blues in the box. It's done. And if first guy gets red, okay, now it's the second guy. Still have 2 cases. Get R or get blue. If it is blue, it's also fine. Right? Then the third one. The third person will still have some two choice, red or blue, right? If it is blue, it's fine. And if it is red, it's also fine. It's also fine, right? Because the only another blue is left for the fourth one, for the fourth people. Now we want to find the probability. This one. We have 4 cases, right? We call this is B1, this is B2. Oh no, I already have A1. AI is eyes people get blue. So this is AI. This is A1, event A1. This is the event A2. This is the event A3. This is event A4, right? So this is the first guy get that blue bar. Only if first three, all of them get red. Right? It seems like he didn't need to do anything. He can have the blue bar. Then the probability. Okay, we use the law of the total probability, but we need to use it several times. This part we use 1 time, right? The probability law of total probability. I have this one, right? I have a graph looks like this. Oh, this is just for 2. I have more. Yeah, it's like this, right? The probability, then separate. Okay, that's it. But now we have more. We have more, right? You see, we have we have more, right? Here just 1, 2, that's it. But we have 1, 2, and 3, and 4. But we can use this formula time and time again, right? This formula can always be used, right? So we use it several times. Then the calculation like this. Probability of A1, it is just this. Oh, I didn't put the probability. Totally 4 bars. So 1 is blue and 3 are red, right? And the probability here, now you only have 2 because you pick 1 red out, so you have 2 red and 1 blue in, right? Total is 3 bars. So 1 is blue and 2 are red. And then here's after you pick second red, you only have 1 red, 1 blue in the box, right? So it's a half chance. And last one, okay, that is 1/1. It's just 1 blue bar, right? It's 1. It's 100%. Okay, then now we can calculate PA1. It is just this one, 1/4. It's 1/4. All right. Okay, we have the first answer. Second one is PA2. PA2, probability of A2. Now I need to calculate along this way, right? Along this way. So it is okay, along this way. I only need this property. Along this way, that is 3/4 times 1/3. So I have 1/4. Now this property is also 1/4. And property of A3. This is A3 is here. Then we calculate along this path. So you just times these 3 numbers together. It is 3/4 plus 2/3 times 2/3 times 1/2. It is, okay, 3 cancel, 2 and 2 cancel, only 4 left. It's 1/4. I have another 1/4. Right. And the last one. Can you imagine? You see, first guy has 1/4 probability to get the blue bar. The second is still 1/4 chance. The third one is also 1/4 chance. So the last one must be another 1/4 chance, right? If you do not want calculation, you can write it directly here, no problem. And of course, if you just still need want to do the calculation like this, use this trick stuff. Okay, then you can times. Okay, you times all of these together. That will be 3/4 times 2/3 times 1/2 times 1/1. This is just 1, right? This is it's 1/1 is 1. Yeah, it is 3 cancel, 2 cancel, 1 cancel. It's 1/4, right? It is 1. All right. Now we have a result. The 4 guys, they have same probability to get that blue bar. It's funny. It's interesting. The thing like that, yeah. Sometimes you want to check, you want to take the chance, so you can choose do it first, or you want wait at the final guy. Doesn't matter. The probability of each guy get that blue bar is same. All 1/4. All 1/4. All right. Okay. This is one example. We can have another example. Any problem? Okay. Maybe you want to ask for here. This is a law of total probability. You do the summation, right? But here you do not have summation. Are they same thing? I would say essentially are same thing. But you know, the problem, you ask some problem, you ask a different problem, so you do the summation in different way. Here you need all this A to summation, and here you just separate calculate each one. The things is the same thing. You have this tree kind of structure, and when you do calculation, you along the path times them together, right? Things like that. Yeah, we can consider another example. We still use this. Now we can calculate more problems, more result. Like here, I only check A, right? Only check A. You can also check AC and AC, the A complement of A. You can also check some combine of them. Some combine of them. And this one is the most simple one. You just check each, what it is. It's kind of leaf, right? Each leaf, you calculate the number. Right? And here is a summation of several leaves. Right? Okay, now we consider another example. I have two coins. The first one, I would say, first one has 0.6 chance to be face. The second one has 0.48 chance to be face. That means both of them, they are not fair one. So the probability to get face is not half. Okay, now pick one coin. Pick one coin from them. But you don't know which one has more chance, You don't know which one has more chance to get the face. Just two coins. Looks almost the same. You cannot separate them who's who. So pick one and flip it. And you want to see what will happen. Face or tail? Okay, I will say one calculate the probability of face. First one. And of course, you can also know after you get the probability of face, you can know the probability of tail will be 1 minus the probability of face. Now you can also calculate these directly from that tree structure, from this one. Right? You can also directly from this one. All right, and the second one, we want to see like that. I guess I can do probability. You don't know which one is which one, right? You pick one, but you don't know which one is which one. So now you can guess. In your hand is the first coin or the second coin. Now how to guess? You flip it, you can have a result is face or tail, right? So if you get a face, you look at this one. The first has more chance to get face. So if you get face, you will think, okay, the coin in my hand is the first one. You get it? Yeah, two coins. You pick one, and you throw it, you flip it, then you want to see, okay, it is a face. I will say this should be the first one, because the first one get more chance to get face, right? And if it is a tail, you think it's a second one. Okay, let me write down. If you get if you get face, or we say face happen, right? If his face happen, if you get face, you guess the coin in your hand. You pick it in your hand. Is the first one. Otherwise, that means you have a tail, right? You have a tail. You guess the coin. The coin is the second one. You just guess it. Okay. Then I want the probability. Your guess is correct. Correct. Yeah, you give a right guess. Your guess is correct. What it is. All right. So now we have 3 numbers we want to know. Okay. We give that tree firstly. To solve solution, right? The solution. We have the first one, you need to pick a coin, right? You pick a coin from 2 of them. So you have first one in your hand, or you have the second one in your hand, and suppose they are equal likely, half and half chance, and even you do not know what's in your hand, is first or second. It looks totally same. And then you check it is a face or tail, right? You check it is a face or tail. And our question, the first one, which one? The first one, I want to know the property of face. Property of face. So you see, this is a face, right? So these two, it gave you the face. Okay, give you a face. And I use different color. Because these two, this give you tail. Okay, these two combined, that is event tail. And the second problem is if you get a face, if you have a face, you will guess the coin is first one. And if you get a tail, you will guess the coin is second one. And the question is, the guess is correct. You guessed the right one. You see here. If you have a face, you will think it is the first coin. Okay, so this one is correct, right? You think it is a fail. If you have a face, you think it is first, and this is the case. It is really face, really first. If here, this is also, you have this as face, right? You have face, then you guess the coin is first one, but actually this is second one, right? So if this thing happen, you still think it's a second. You still think it's a first. You guess it is first, but it's not first. So this is the case. Your guess is wrong. All right. Now we look at another result. When you have a tail, you will guess it is the third coin, the second coin, right? It will be second coin. So when you have T, you think it's the second coin, but this one, according to it is a result of first one. So this is not correct. And this one, okay, this is correct, right? You have a tail, then you guess it is the second one, and it is really second one. All right. So by this way, we can see these 4 results these two, this is true, this is true. This one give us correct. It is correct. Alright. Okay. Then we can calculate the probability. Oh, I still need probability here. The first coin we have a 0.6 chance to get face. And the second we have 0.48 to get face. Then this part should be 1 minus 0.6 is 0.4. And this side will be 1 minus 0.48, which is 0.52, right? Yeah. Okay, now we can calculate the probability of phase is 1/2 times 0.6, 1/2 times 0.6, this one, right? And phase, this one. The second is also 1/2 times 0.48. So this is 0.3 plus 0.24. That's 0.54. We have a little bit more chance to get phase. Okay. And the probability of tail, it will be similar thing, right? Tail, this is tail, right? This one and this one. So it is the top one, the higher one is 1/2 times 0.4, and the second is 1/2. It's 1/2 times 0.52. So this is a 0.2 plus this is a 2.6. Totally is 0.46. You can also, because you have the first one, you can just use 1 minus 0.54. That is 0.46. You get the same result. Okay, so this is for the first questions. We want to know the probability of phase or tail. Now, second one is a little bit complex. We want to know the when you do a guess. You don't know which one is which one, so you want use this experiment to guess, to separate these two. So whether your guess is correct, I would say this is correct, right? So the probability of this correct, you do the correct decision, is this one and then this one. So now is 1/2 times 0.6 plus 1/2 times this is this one. This one is 0.52. 0.52. Alright. This is 0.3 plus 0.26. Then is 0.56. So you have this chance to get right get a right result, a right decision. Yeah. But just it's still not 100, right? But you can guess like this. It's a kind of estimation. That's all for today, and so we will see next time. And today we will have some new homeworks. So you can find the new homework from the Blackboard, same location with the first homework, right? You should know how to do it because this is the second one. The first one you already did it. And the coverage of this homework is today and Friday, then next class, and its due time is next Monday. Alright, okay, see you next time. Bye bye.